Namaste. In physics, we are seeing so many relationships like mass is directly proportional to inertia and force is directly proportional to the product of their masses and all. In this video, I am going to explain the logic behind adding the constant of proportionality in so many derivations. I have taken an example of universal law of gravitation. Here I have displayed the universal law of gravitation. You can go through that. In the first relation, you can observe that force exerted between any two objects is directly proportional to the mass of the first object, and second, again the mass of the second object. Third equation, you can see the force exerted between any two objects is inversely proportional to the square of the distance between them. And when you combine all the first three equations, you will get a relationship like force exerted between any two objects is directly proportional to the product of their individual masses and inversely proportional to the square of distance between them. If you remove the proportionality and we are adding equal to sign for that relationship, what we get, we are going to add one constant of proportionality. In this case, we have added capital G. It means G is a constant of proportionality having a exact value of 6.67 into 10 to the power of minus 11 Newton meter square per kg square, and this is the constant in the whole universe. That we know that. But what is the logic behind adding that constant of proportionality? Do we thought of whether we try to understand the logic behind that? In each and every concept, understanding the logic behind it is very important. Let me explain you why we are adding the constant of proportionality in the most of the cases like this. For example, if you go to one shop and if you buy some pens over there, we can say in a form of relationship, that is, amount is directly proportional to the number of pens you buy there. Amount to be paid to that shopkeeper is directly proportional to the number of pens you buy. This, like this, in general statement we can write for that particular scenario. But I cannot say the amount I need to pay to that shopkeeper is equal to the number of pens I buy, because both are totally different. If I buy 12 pens, it does not mean I have to give him 12 rupees, right? It does not make any sense. So, how I can find the exact amount to be paid to that shopkeeper? I want to know the cost of each pen, right? And then I have to multiply to the number of pens I purchased over there. So like this, you can observe there amount I need to pay. If I am adding, if I am removing that directly proportionality with the equal to sign, I have added a constant of proportionality k over there. It means I have to know what is the cost of the one pen. For example, you think that is 4 rupees is the cost of one pen. Number of pens I buy, that it depends. If I buy 5 4 20 rupees, it happens. So if you want to know the exact value of the amount to be paid, or if we want to know exact value, then we have to go for the equation. We have to add over there constant of proportionality. That is the reason we are adding the constant of proportionality to remove the direct proportionality gives us the relationship like amount increases when the number of pens purchased increases, right? But it does not give exact amount what I need to be paid to that shopkeeper. When I add the constant of proportionality and if I convert that into equation, then we will know the exact amount I need to pay to that shopkeeper. Like this, generally in a simple way, we can make our student to understand why we are adding the constant of proportionality in these type of cases. Dhanyavad.